The new topic, cosmology and astrophysics. So in this topic, you will study about the Newton law of gravitation, the gravitational force, gravitational field, the relation between the gravitational and the electric field, the comparison, as well as different laws related to the black body or finding the radiations flux of star, the types of the star, and different ways to calculate the distance between the stars and distance between the star and the earth. So first one, Newton law of gravitation. What is Newton law of gravitation? According to this Newton law of gravitation, state that the force of attraction, because gravitation force is always attractive, the force of attraction between the objects is proportional to product of the masses and inversely proportional to distance between the masses. So if we have two objects, two masses, whenever the mass is there, there is always a force of the gravity. The strength of this force, depending on which factor, according to Newton law of gravitation, like example, if you have two objects, one mass m1, another one is mass m2. As there are masses, so they will apply a force that is known as a gravitational force, and this gravitational force, the m1 apply a gravitational force on m2 and m2 will apply gravitational force on m1, and according to Newton law of gravitation, the force of the gravity between the two objects is directly proportional to their masses, means the product of the masses. So greater the product of the mass, stronger force will be there. Like example, if a book is placed on the table, a book is having a mass and you are also having a mass. So why the book is not moved towards you, or why you're not able to move towards the book? Because there is a gravitational force, but that gravitational force is weak gravitational force. Why? Because the product of the mass of the book and yourself, when you take the product of the mass of the book with yourself, that will give a smaller value. That's why there is a gravitational force, but it will be a weaker gravitational force. So according to Newton gravitation law, the force of attraction between the two masses is directly proportional to product of the two masses, and it is inversely proportional to the square of the distance between the two. And when we take a distance, we take a distance from their center. For example, this is the center of m1, this one is center of m2. So this force is inversely proportional to square of the distance between the two masses. If this distance is given by r, so F is inversely proportional to R square. What is this meaning? It means it follow an inverse square law. Inverse square law means if the distance between the two objects, the two masses, their center double, then the force, if one is increased, the other will decrease by square. So if distance is double, the force will decrease by 4. Same thing, if distance is increased by 3, the force will decrease by 9. If distance is multiplied by 4, then the force will decrease by square of 4, which is 16. So it follow a inverse square relation. When we combine these two factors, as according to Newton's law of gravitation, that the force of gravity between the two objects is proportional to product of the masses and inversely proportional to square of the distance between them. So when we write, we can say F, the force is proportional to product of the masses m1 m2 and inversely proportional to square of the distance between them, so r square. Whenever we replace this proportionality sign, because this is a mathematical expression, if we want to make an equation, it must be balanced left and right hand side. So whenever we replace the proportionality sign, we always replace with equal to and constant. So here we replace with equal to and constant. That constant is g, which is also known as gravitational constant, and constants having a fixed value. Some of the constants, their value changes according to the condition, according to the medium, but the universal, this is a universal law of gravitation, so its value remain same throughout. It is independent whether the two objects are on the surface of the earth or on the surface of the Jupiter or in the space. The value of the g is a constant, which is 6.7 into 10 to the power minus 11. And what will be the unit? If I'm finding the unit of g, we know the force is Newton, so this will be Newton. Distance is meter, so it is squared, so meter will be multiplied there, it will become meter square, and divided by mass is kilogram, so it will become kilogram square. So according to Newton's law of gravitation, that the force of attraction between the two masses is directly proportional to product of the mass and inversely proportional to square of the distance between the center of the two masses. And how these how this gravitational field is applied by exchanging a particle bosons, which are known as gravitons. Like the region where the gravitational force can be experienced, that region is called gravitational field. And how the particles are exerting a gravitational force by exchanging a boson, which is called a graviton. But existence of, like, this is theoretical till now. Experimental evidence does not show till now, like not able to prove the experimentally this particle existence. So this is still a theoretical particle, that it is there, which is present when the two particles are applying or two objects are applying a gravitational force. Is it clear? The Newton law of gravitation, or universal law of gravitation, you can also say. Then we can use this universal law of gravitation to find the mass of the earth. How we can use it to find the mass of the earth? We can use it to find the mass of the earth. We can use it to find the density of the earth as well. So practically how we can find the mass of the earth? Example, an object is there on the surface of the earth. So according to Newton, if mass of object is m and the mass of earth is me, and distance between them, practically, like the distance between them, if it is on the surface, it will be practically, it will be a bit more than radius of the earth, but in comparison, it, you can clearly assume, because the object center of the mass will not be at the bottom, it will be somewhat here, so practically it will be a bit more than that, but this distance will be very small compared to that of earth. So we can simply say the distance between their center is equals to radius of the earth. So according to Newton law of gravitation, the two objects, one is the earth, another one object of mass m is placed. So Newton law of gravitation states that the force of attraction between them is equal to F is equals to g m m1 m2 over r square. So here we have force F, which is equals to G, the gravitational constant, mass of Earth, mass of object divided by distance between them, which is equal to radius of Earth square. But as you know, when the Earth is applying a force on the object, the force which this object will experience, the gravitational force, and that is also known as a weight. Like if I experience a force of 700 Newton by Earth, so it means, or Earth is pulling me by a force of 700 Newton, so actually that is my weight. So I can simply replace this force by the weight. So I can say weight is equals to G, the mass of Earth, mass of object divided by radius of Earth square. W is equals to mg, the weight of object is mass multiplied by gravity. So I can say mass into gravity is equals to G, the mass of Earth, the mass of object divided by radius of Earth square. This mass will cancel with mass. So we have the value for the gravity. The gravity is equals to gravitational constant, mass of Earth divided by radius of Earth square. So this formula can also be used even not only for Earth, it can be used to find the gravity of different planets, different like different scenarios. We can use this. Gravitational constant is there, but our main focus is to find the mass of the Earth. So how we can find the mass of the Earth? If I need mass of Earth, that is our subject. So the mass of the Earth is equals to gravity multiplied by radius of Earth square divided by the gravitational constant. So this is a formula which we will use to find the mass of the Earth. Is it clear? Same way, we can also find the density of the Earth. How we can find the density of Earth? So we already worked out this formula that the mass of the Earth is G, radius of Earth square divided by capital G. Small g is the gravitation expression due to gravity. Small g is expression due to gravity, and capital G is a gravitational constant. And what about the volume? In practical, the Earth is not a perfect sphere, but for calculation, we'll consider Earth is a perfect sphere. So radius of Earth is RE, and volume of the sphere is 4 by 3 pi r cube. So volume will be equal to, the volume of the Earth is equals to 4 by 3 pi r cube. So to get the density, as we know, density is equals to mass per unit volume. The mass of Earth is small g, radius of Earth square divided by capital G, and the volume is equals to 4 by 3 pi r cube. We will then simplify this equation and we'll get the density of Earth, average density. That's not the actual density, it's an average density because even the distribution, the assumption is there that Earth is perfect sphere, but in practical it's not a perfect sphere. We can also use this universal law of gravitation to find the time period of vibration or motion or oscillation. Example, finding a time period of a satellite. How we can find the time period of a satellite? Example, Earth. We can have different types of satellite. If it's a geostationary satellite, then it will remain at a fixed position with respect to a position of the Earth. So here the center is there, the Earth, and a satellite This is a position a satellite is there. The distance from